All right, so with ellipses then, we looked at the definition. We talked about major and minor axis. Okay. And then we have the standard form for an ellipse. So if it extends horizontally, you can see that the vertices are on the ends of the major axis, and the co-vertices are at the end of the minor axis. Okay. If it's vertical, then they just switch. The major axis is the vertical axis, minor axis is the horizontal. And so the vertices and the co-vertices switch. Notice where the focus is. Okay. On the horizontal, the focus is on the major axis inside, but on the vertical, it's also on the major axis. So when they talk about a focus or the foci, that's always on the major axis, and we have a way to find that also. So here they talk about the values of a, b, and c and their relationship. What does that relationship look like? So the values of a, b, and c are related by the equation c squared equals a squared minus b squared. Okay, it's very close to the Pythagorean theorem, except for the fact that it's a minus instead of a plus. And when we get to hyperbolas, it actually is the Pythagorean theorem that's used for the relationship between c squared, a squared, and b squared. Also note the length of the major axis is 2 times a, and the length of the minor axis is 2 times b. Right? So always when we're talking about an ellipse, a is going to be the larger number and b is going to be the smaller number. Always. Okay? So here's a standard form for an ellipse. If it opens horizontally, then the equation is x squared over a squared plus y squared over b squared equals 1. And if it opens vertically, okay, then it's y squared over a squared plus x squared over b squared equals 1. Now, given that, I don't care which way whether you write x first or y first here. Actually, I prefer that you write x first, but it really doesn't matter. Just understand that if it opens horizontally, the bigger number is under x. If it opens vertically, or if it stretches vertically, the bigger number is under y. Okay, the major axis is always longer. Okay, that doesn't apply. It's different with hyperbolas. Okay, all right. So our vertices then are shown here, foci and co-vertices. So vertices are A, co-vertices use the letter B, and foci use the letter C. So we're going to use the standard form to write an equation for an ellipse. And here they give us it's centered at the origin. It has a vertex at the point 6, 0 and a co-vertex at the point 0, 4. And one of the things that we need to do is one of the things you might want to do is actually graph those 2 points. And you could actually sketch a graph. So for instance, I could do this. I could go here. The vertices are on the major axis. So 6, 0 is here. So what else would be a point on the major axis? Where at? Yeah, at negative 6, 0. Okay, so here's negative 6, here's positive 6. And the co-vertices are at 0, 4 and 0, negative 4. So which way is this stretch then? Horizontally, okay? So there's the first thing we need to choose is the fact that it's horizontal, which means that it's x squared over a squared plus y squared over b squared equals 1. And one of the biggest mistakes that people do is they forget the 1, okay? And it is equal to 1 always. Okay? So then step 2 will identify the values of a and b. And if the bigger number is a, the smaller number is b. It's that simple, okay, as far as the vertices and co-vertices. Okay? So then a equals 6 and b equals 4. Now, if they tell you what the focus is, that's C. Okay? And then you have to use that relationship between A, B, and C. So to write the equation then, we just plug in A and B. So we get x squared over 6 squared, which is 36, plus y squared over 4 squared, which is 16, equals 1. Okay. So we need to know, what do they give us? They give us vertex and covertex. All right, good. That's always A and B they're giving us information about when they say covertex and covertex. Okay. Let's look at letter B here. So we're going to go through those 3 steps again. Okay. Which is our appropriate equation? Identify values of A and B, and then write the equation. Now, here's the thing. They tell me the covertex. Is that A relate to A, B, or C? B. Okay. So this is B. The focus relates to what? C. Okay. So that means we're going to need to find A. So we have to use that relationship that A squared minus B squared equals C squared. We're going to have to use that to find the value of C. So I know that B is 5 and C is 3. Okay. So which way does this open? Or which way does it stretch, horizontally or vertically? Okay. In gallery, why do you know it's vertical?
Because the covertex is 5, 0, and the last one is 0, 4, so it's just split.
Okay. The covertex is on the x-axis, right? Okay. So since the covertex is on the x-axis, I know that it's got to be stretched vertically. Also, the focus is on the y-axis, so it has to be stretched vertically. Focus and vertex are always on the same axis of which way it's stretched. Okay. So let's find the value of A. So we know it's stretched vertically, so this is vertically. That means it's going to be x squared over B squared plus y squared over A squared equals 1 when I'm done. This is the form we're going to use. Like I said, you can put x first or y first. It doesn't matter, okay, when it's vertical. All right, so we got to find A. So we'll put 5 in for B and 3 in for C. And really, do I need to find A or do I only need to find A squared? Really, we only need to find A squared. If I was graphing it, I would need to know A. But since I'm not graphing it, I just need to know A squared. So A squared equals, so I'm going to add 25 to both sides. And what's 9 plus 25? 34. So this equation will be x squared over, B is 5, so that's 25, plus y squared over A squared, which is 34, and equals 1. And so remember, whichever way it's stretched, the bigger number is always under that letter. So if it's stretched horizontally, bigger number is under X. Stretched vertically, bigger number is under Y. Now here is the standard form for the equation of ellipse if it's not centered at the origin. Notice, what are the letters we're using for H and K again? Yeah, H and K. We're using H and K for the letters for the center once again. Okay. The only thing that this changes from at the origin is the fact that everything just moves left, right, up, or down, depending on the values of H and K. Everything else is basically the same as it is at the origin, except we're just moving things over. Okay, over and up, over and down. Okay. Right. This is, if you're going to put anything on your note card, this is it. Okay, you're going to put this on your note card. Right. And you notice where we talked about the confusing, because this looks like just like the equation for a circle, doesn't it? Except I have A squared and B squared in the denominator. Okay, so it's very similar to the equation for a circle, except with A squared and B squared in the denominator. All right? So let's talk about graphing then. So here they want us to graph this ellipse. And actually, I do want you to, when they ask you to do this, I would prefer that you did it on graph paper, just to make sure that your graphs are accurate, okay? Because if your scales are not the same, you could end up with a circle when you're supposed to have an ellipse, okay? Right? And that's, all right. So first of all, we want to rewrite the equation showing the things that are squared. So I'm going to rewrite it first of all. So it says x plus 4, that quantity squared, over 7 squared, plus y minus 3, that quantity squared, over 4 squared, equals 1. In other words, I want the denominator, I want things squared, so that way I can easily identify the values of a and b. Okay? So then I know that a is equal to, and a is always the biggest number in the denominator, 7. b is equal to 4. H is our x-coordinate for the center, and that would be -4. And k, our y value, is 3. Okay? All right. So, when we graph, we start out and we graph the center. Okay? And in this case, the center is at -4, +3. Now, I'm probably going to have to change my scale here a little bit. Now, the 7, the bigger number, is under what? The x, right? That means from the center, I'm going to go 7 left and 7 right. Well, I can go 7 left, okay, or to the right, which puts me at +3, correct? Right, but I have a problem going to the left, so I need to change my graph here a little bit. Let's bring this down. So if I go 7 to the right, I'm at 3. If I go 7 to the left, I'm at, oops, need one more, 11. Okay. All right, so I've gone 7 left and 7 right from the center. Okay. And I'm going to go how far up and down? 4. So we go up 4, we're at 3, 4. Let's see, 1, 2, 3, 4. And 1, 2, 3, 4. Okay. And then I can draw my ellipse. And there's the graph. So graphing them, we need to find, basically all we need to do is identify A, B, H, and K. And then you need to know which way they go. So I'm always going to graph the center first. After I graph the center, I look for the bigger number. Okay. If it's under the x, I'm going to go that way, that much left and right. Whichever one's under the y, I go that far up and down from the center. And that's all you have to do to graph the ellipses. All right, example 4, we have an application problem here. It says a city park in the form of an ellipse with an equation of x squared over 50 plus y squared over 20 equals 1, measured in meters, is being renovated. The new park will have a length and width double that of the original park. Find the dimensions of the new park. So first thing we're going to do is we want to find the dimensions of the old park. All right? And then we can determine what the dimensions are of the new one. So let's actually make a graph. All right, so the original park is x squared over 50, y squared over 20. Where's the center at? Origin, okay? And then the values of a and b are the square roots of those numbers, right? Not very nice numbers, but they'll work for us, okay? The square root of 50 is just that, right? Square root of 50. Right, let's focus on it there for a moment, which is approximately 7, right? Okay. All right, so we're going to go left here. So this is negative square root of 50. Over here is positive square root of 50. Okay. And then we're going to go up and down how far? Square root of 20. Okay. Okay. Now, what is the value of A and what is the value of B? You already told me what they are. Okay. Square root of 50 and square root of 20. Okay. All right. Now, so the new part, it says the width is double. Okay. Which means then the value of A for the new part is going to be what? It's not square root of 100. It's 2 times square root of 50. And the value of B would be 2 times the square root of 20. Okay? Now, one thing is that we can come up with better numbers than those. Okay? Because, can we simplify the square root of 50?
25 times 2.
Yes. Square root of 50 is square root of 25 times 2. Okay? So this is actually going to be 10 square roots of 2. Okay, everybody all right with that? Okay. And this then, square root of 20 is 4 times 5, right? So that would be 2 square roots of 5. So this would be 4 square roots of 5. Okay. So now, okay, they want the dimensions. What do you think dimensions mean? When we're talking about an ellipse, what are they talking about with the dimensions? Okay, what? The length and width, which means all the way across, right? Okay. Well, this number here only represents the value of A. So the value of A is only the distance from the center to one side. So to get the dimensions then, we're going to have to go all the way across, which means I have to do what with these numbers? We have to double them. So the dimensions of this part is going to be 20 square roots of 2 by 8 square roots of 5. Okay. Does that make sense? Okay. All right. Yeah, I know. That's a lot of work. Okay. And then they want us to write the equation for the design of the new part. Well, has the center changed? No. Nope. Okay, so we still have x squared and y squared and 1. So now we have to square this number and square this one. Oops, not 4 but 8. I'm sorry. Hold on a second. What numbers am I squaring to get for the equation? Am I going to square the 20 and the 8 or the 10 and the 4? Which numbers represent A and B? Yeah. This is A still, and this is B for the new one. The dimensions represent all the way across, not halfway, which is what the values of A and B are. So we're going to square 10 square roots of 2 and 4 square roots of 5. So that means we're going to have x squared over, let's see, 10 squared is, and if we square the square root of 2, what do we get? 2. So what's 100 times 2? 200 plus, square 4 we get? 16, and 16 times 5 is 80. And there we have that equation. Okay. So the dimensions is a tough part because you've got to think about what numbers am I using for A and B. And you have to be careful with them. Because A and B is only halfway across, not all the way across.